Hey guys, welcome back to another edition of Geometry. This is Mr. A leading the way, and we're in section 3.2 today. Okay, I did a little rhyming thing there. Did you see that? All right, so what you might have thought when we went over in 3.1, you might have thought, oh, it's so big deal. Why do we call all these different types of angle pairs? Why do we call them what we do? Who cares? Okay, so today that's what we're going to be talking about, why it makes a little bit of a difference and how we can use those to solve some things. All right, so today, first of all, our objectives. We're going to use theorems to determine the relationships between specific pairs of angles, and then use algebra to find angle measurements. I always like it when we use algebra. Okay. So let's start with this today. Oh, okay, well, this is actually 3.2. So corresponding angles. Remember last time we talked about corresponding angles. All right, so if you remember, we talked about corresponding angles, like for example here are 1 and 3. So 1 and 3, it's just corresponding means it's like the next block over, but the corner house just the next block over, that same corner. All right, so what's happening now is we have to have parallel lines. Before, the two lines that we had, where we had a transversal cutting across it, were not necessarily parallel, but now we're saying, hey, if these two lines are parallel, then what do we know about corresponding angles? What we know is that they are congruent. Okay, so if we see that these are two parallel lines and we have a line that cuts across it, we know, hey, 1 and 3 are the same. They're congruent. 2 and 4 are the same. They're congruent. 7 and 5 and 6 and 8 are all congruent. Okay, so that helps us then when we've got a little diagram here and we know one of the angles, we can figure out the other ones, okay? So let's take a look and see what we can do with this. All right, so first of all, it tells us here in this situation, measure of an angle 11 is 51. All right, so this is 51 degrees up here. All right, notice number one that X and Y, those lines, have these little arrows on them, so guess what? They're parallel. So this will hold true what we've just been talking about. And so in this situation, then we say, well, 11 is 51. What are we trying to find? We're trying to find the measure of angle 15. So this is the one that we're trying to find right here. We're trying to find that one. And so he said, well, how are those related? 11 and 15, guess what? They're corresponding angles, aren't they? They're the same, just next block over, that same corner house. So this would also be 51 degrees because they have to be congruent to each other. So so the measure of angle 15 has to be also 51 degrees. And, you know, which postulates or theorems there? Just that was, you know, I'm not so worried about the name. You know, I want you to know that they're corresponding angles, but, you know, the corresponding angles theorem. Okay? And that's why we know that, because they're corresponding angles. Okay? All right. How about another one? All right, so once again, angle 11 is 51 degrees. I'm going to write it in here. Well, let's find this time the measure of angle 16. Well, where is 16? Here it is down here. Now this is a little bit more interesting. What could we do here? Okay, well, what we have to do here is we have to think back to something that we learned in chapter 1, in addition to what we've just learned here now, to help us. Okay, so let's do this. Let's just start by saying, you know what? If what we did in the last example is we said if angle 11 was 51, then angle 15 has to be 51, right? Okay, so we just had done that and we knew that, and that was again by the corresponding, because they're corresponding angles. Okay, so we knew that 11 and 15 are congruent, so we know that angle 11 is congruent to angle 15 because of the corresponding angles. Well, now how could we got 15 and 16? Well, they're right across from each other. Can you think of lines that are straight across from each other? Number one, what are they called? And number two, what do we know about them? Their measure. Okay, so I'll give you a hint here. Lines that are straight, or angles that are straight across from each other, when there's two straight lines, are vertical angles. What do we know about vertical angles? They're also congruent, aren't they? Vertical angles are also congruent. So we then can say that 16 is congruent to 15 because they're vertical angles. So therefore, 16 would also be 51 degrees. Wow, isn't that cool? We pulled together a couple of different things there to figure out what angle 16 was. Okay, we've got, as you can kind of imagine, there's a few more things here. And so remember all those different angle pairs that we had? There's some special things about those as well. So first of all, the alternate interior angles theorem. Okay, so alternate interior angles. Remember what alternate interior angles were? They both had to be interior, and then alternate is like on the opposite side of the transversal. So 1 and 3, 2 and 4. Guess what? Alternate interior angles are congruent. Okay, that's good to know. Let me jump down to the last one here. I'll come back to the middle one in a second. Alternate exterior angles. So remember, alternate exterior angles have to be exterior, and they have to be on opposite sides of the transversal. So, like for example, 8 and 6 are alternate exterior angles. And guess what? Alternate exterior angles are congruent. They're also congruent. All right, now what kind of is kind of in the middle here is consecutive interior angles. Remember, that was another one we talked about, consecutive interior, which means they both have to be inside and they're on the same side of the transversal. So for example, here it would be like 1 and 2. Now if you look at this, just by looking at it, you go, 1 and 2, they don't look congruent. Everything else was congruent, but these don't really look congruent. You know what? Here's the thing about these. They are not congruent, but what they are is they are supplementary. Okay, so they're supplementary, which means what? That they add up. They add to be 180 degrees. Okay, remember we talked about supplementary before. And so, and if you think about this, this kind of makes sense here too, because remember what we've just been talking about is that angle 2 and like this angle over here, whatever it is, I'm going to name it, oh actually here, down here they've named it 5, I'll call it 5. Angle 2 and angle 5 are corresponding, so they're equal to each other, right? Well, 5 and 1 together, we've looked at that before, they're a linear pair, which means they add up to be 180. So 2 and 1 would also add up to be 180. Okay, so remember those. We'll do a few examples here. All right, floor tiles. The diagram represents the floor tiles in Michelle's house. We're going to assume that all these lines are parallel. If the measure of angle 2, here's angle 2, is 125. So this is 125 degrees. It's kind of hard to write so small in there. That's 125 degrees. Find angle 3. All right, so here's angle 3. Can we, now there's a lot of lines crossing here, but what we want to do is, what we have to do is figure out what line makes up part of both of those angles. And if you look here, you notice this line right here makes up part of angle 3 and part of angle 2. So that's the transversal line. Okay, so the two parallel lines are these ones right here. So this is interior and these are exterior. Okay, so interior is in here, exterior, exterior. So both of these are interior. So what is that going to be? They're both interior, so they're alternate, oops, there we go. They're alternate interior angles. And so, I'm sorry about that. Alternate interior angles are congruent, right? And so that means this would also be 125 degrees. So the measure of angle 3 would equal 125. Okay, alternate interior angles are congruent. All right, example 2b. Again, same diagram here. And again, they said that angle 2 is 125. Find angle 4. Ooh, here's angle 4 down here. Now what can we do? Okay. Well, let's think through this again. With what we've learned so far, what about, well, we just talked about in the last example that 2 and 3 are alternate interior angles, and so we could make this one also 125, angle 3. And so now if we get this being 125, 3 and 4, is there anything you can figure out between 3 and 4? What's their relationship? Together they make a straight line. So what kind of angles are those? They're supplementary, or in this case a linear pair, which is supplementary. So that means they add up to be 180, right? So basically if we take 125 and add it to 4, we're going to get 180. So what we can do is just 180 minus 125, and that gives us what, 55 degrees? And so the measure of angle 4 is 55. Okay, so see how you can pull together certain things, alternate interior angles and supplementary. Or in another previous thing, we did vertical angles and corresponding. So you can kind of tie those all together to figure out what you need. Okay, so now this leads to some algebra. So what we're going to do here now is we know some algebraic expressions here for certain angles, and we're going to be able to find x or solve for x. So angle 5 is 2x minus 10. So angle 5 is 2x minus 10, and 7 down here is x plus 15. All right. Well, those two angles, 5 and 7, what's their relationship? Do you remember what we call that? Oh, by the way, let me mention something else that I just noticed here. Remember I talked about the arrows show that these are parallel? If we already have one set of parallel lines, here's another set of parallel lines. So you notice what they did? They made 2 arrows. So you know that the 2 arrows, those 2 are parallel, and the one with 1 arrow are parallel. Okay, so just kind of like with the arcs, you know, number of arcs or the number of marks and segments. So it's all the same principle. All right, so 5 and 7 are what? They're corresponding angles, okay? They're corresponding angles, and what do we know about corresponding angles? They are equal to each other. Okay, so what can we write for our equation? We would write what? 2x minus 10 has to equal x plus 15. So we know that those two have to equal each other. Now we've got an equation and we can solve it, right? So we're going to do minus x and then plus 10. So 2x minus x is 1x, and 15 plus 10 is 25. Yay. So we got that x is 25 because we knew that the corresponding angles are congruent to each other. Okay? All right, how about this one? As you would expect, it's going to get a little bit more complicated. So let's fill in what we know. We know that angle 8 is 4y, so this is 4y. And then angle 4 up here is 4 times y minus 25 degrees. Okay. Well, let's look at the relationship that we have. Well, both of these, the way that, look at the line, that this line here, line N, forms part of 8, and it also forms part of 4. So this is the transversal. These are the two parallel lines. So this is interior in here. This is exterior. This is exterior. All right, so these angles are both exterior. The only thing that we have where they're both exterior is alternate exterior angles. Well, these aren't alternate, they're on the same side. Alternate would mean one here and one over here, like 8 and whatever this one would be over here. All right, well, we have to figure out something else here that we can work through this. So let's see. What about if we had angle 8 and angle 6? What could we say about those? Well, those are corresponding angles, right? Same corner house, just next block over. So they're congruent. So that means angle 6 would have to be 4y degrees as well. So now that we know that angle 6 is 4y, and we know that angle 4 is 4 times y minus 25, these two together, hey, if you look, they're right next to each other. They make a straight line. They're a linear pair, which means they're supplementary. So if I add them together, 4y plus 4 times y minus 25, it will have to equal 180. There's my equation. Hopefully this is all kind of making sense here, but you have to really put several things together sometimes to come up with these equations. All right, so let's just go ahead and solve this. I'm going to distribute the 4. So that's 4y minus 100. But don't forget this 4y out here. 4y and 4y together is 8y. Plus 100. Since we want to go to the opposite side, we do the opposite thing. I hate it when that happens. And then that means 8y is 280, it looks like. And then divide by 8. And so 280 divided by 8, it looks like it's 35. So y equals 35. Okay? All right, last thing and we're done. This should kind of make sense to you here, but the perpendicular transversal theorem, all it says is if you have two parallel lines and you have the transversal is perpendicular to one of them, it will also be perpendicular to the other. And if you think about it, that makes sense because remember these two lines here, or these two angles here, sorry, those two angles, they're both 90. Well, what are those? Those are corresponding angles. And we already know that corresponding angles are congruent to each other. So if this was perpendicular and make 90, this would also have to be 90. And so this is really just the same thing, but, you know, a little bit more specific to perpendicular, but it really is the same thing. Okay? So that's it for section 3.2. Appreciate you being here. Hope you learned something today, had a good time. I'll catch you next time. And this is Mr. Anderson signing off. Bye.